So we have something like this. We have y is equal to 2x plus 1, and we need to differentiate that. So we know that if we were to differentiate something like this, it would be dy over dx, and that would just equal 2, okay? But what is actually happening here with the y, okay? Now with the y, it goes to dy over dx. And now up to this point, we've just learned that when we have something like this and we want to differentiate it, when we've got y equals an expression, it's always going to be dy over dx is equal to whatever, and then we just differentiate with respect to x. But now we're going to be looking at some implicit equations where it's going to make a bit more sense, and we're going to get a bit more of an understanding of why we have that dy over dx. So right now we have 3y and we want to differentiate that with respect to x, but we don't have any x value. So how would we differentiate this with respect to x? So what we can do is we can actually use the product rule. So if we use the product rule, then let's let u equal 3, and then we'll let v equal y. And if we differentiate u with respect to x, we get u dash is just equal to 0. And then we get v dash. If we differentiate that y with respect to x, because y is a function of x, that would become dy over dx. And then at this stage, we just use the product rule. So that will be u times v dash, which is going to be a 3 dy over dx. And then u dash times v, that's just 0 times y, so that will just give us 0, so we don't include it. Therefore, if we differentiate 3y with respect to x, it is just going to be 3 dy over dx. And an easier way to think of this too is what you can think of is if you have something like this, you can differentiate it as if you were differentiating with respect to y, right? You can just differentiate it like normal. So if we had this 3y, well, if we was to differentiate that with respect to y, for example, it would just be a 3, okay? And if it would just become a 3, and then we just add the dy over dx at the end. So again, you can just differentiate it like normal and then just add the dy over dx. Another example is if we have y to the power of 3, again, we could differentiate this as if we were differentiating with respect to y. So then that would give us a 3y squared, and then we just add the dy over dx at the end. So that's one way you can do it when we are differentiating with respect to x, but we just have y values. Now, what if we had something like 2xy and we want to differentiate this with respect to x? So this one is a bit more challenging, but we can just apply what we've learned in the past to work it out. So for example, this is in the form of like the product rule, right? We can use the product rule to work this out. So if you do that, therefore we can let u equal 2x, and we can let v equal y. And if we differentiate the u, so we get u dash, well, that would just equal 2. And the v dash, remembering that we are differentiating with respect to x, that would just be dy over dx. And then we could use a product rule, which would simply just be u times v dash. So in this case, it would be a 2x dy over dx, and then that would be plus u dash times v, which in our case is 2y. Okay, and then if we wanted to work this out, if we want to get dy over dx by itself, then all we need to do is we can just bring that 2y to the other side. So therefore we would have dy over dx, and then we'd have the 2x here, that is equal to a minus 2y. And then simply we can just bring that, divide both sides by 2x, and we'll be left with dy over dx, and that would equal minus 2y over 2x, okay? And then you can even simplify down even more, because that will just give us minus y over x. Okay, so now we're going to move on to some examples. So now for this question, we need to find dy over dx in terms of x and y, where we have x to the power of 3 plus x plus y to the power of 3 plus 3y is equal to 6. So for the x values, it is very simple because we're differentiating with respect to x. For x to the power of 3, we would get a 3x squared. Then that x would turn into a 1. And now with the y to the power of 3, well, as we learned earlier, that would be 3y squared dy over dx, and that 3y would just be a 3 dy over dx. And then with that 6, again, you've got to differentiate on both sides. That's the key here, differentiate on both sides. So if you have that 6, well, if you differentiate the 6, it just becomes a 0, okay? And now we've done this, we want dy over dx. So all we need to do is collect our dy over dx terms together, and then anything else can just go to the other side, and we can start to get it in terms of dy over dx. So now at this stage, what we can do is we have this 3y squared plus 3. Okay, that is all dy over dx. And then we have that is equal to minus 3x squared minus 1. And then at this stage, fairly simple, just need to now move that 3y squared plus 3 to the other side. So we're left with dy over dx that is equal to minus 3x squared minus 1. And that is all over 3y squared plus 3. So for this next question, we have 4xy squared plus 6x squared over y is equal to 10. We need to find the value of dy over dx at the point of 1, 1. So again, if we have that, well, again, now we have this 4xy squared and we have this 6x squared over y, okay? So again, because y is a function of x, okay, therefore, we're going to need to use some form of a product rule, or we can use quotient rule as well to work this out. So I'm going to use product rule for both of these. You can use product rule, and for that second value there, you can use a quotient rule. It's really up to you what you want to do. So to start off with, if I have a 4x squared, then if we use the product rule, then we'll let u equal 4x, and we'll let v equal y squared, okay? Now, if we differentiate with respect to x, that 4x, it becomes a 4. And if we differentiate that v with respect to x, it becomes a 2y dy over dx. Remember that y is a function of x, okay? That is why we do it like this. And then once we've done that, we just do u times v dash. So u times v dash would be a 4x times a 2y dy over dx, which would equal a 8xy, my bad, 8xy dy over dx. And then that would be plus u dash times v, which is a 4y squared. So know that for 4xy squared, if we differentiate that with respect to x, we get an 8xy dy over dx plus a 4y squared. Now, for that 6x squared over y, it's a bit more challenging, but again, you can use a quotient rule because it's already in that fraction form. But for this purpose, I'm going to use the product rule, okay? So to use the product rule, I'm going to move that y to the top, so it'll be a 6x squared y to the minus 1. And now I'm going to do the same thing. So if we have u, we'll make u equal to 6x squared, and we'll make v equal to y to the minus 1. If we differentiate u with respect to x, we get a 12x. If we differentiate that y to the minus 1 with respect to x, you just do it like normal. So you get a minus y to the minus 2, and then you just add the dy over dx at the end, because y is a function of x. And now we've done that, we just put it all together. So we would do, it'll be u times v dash. In this case, that would be a 6x squared, okay? And now what I'm going to do, I'm bring that minus y to the minus 2 to the bottom. So we get a minus y to the 2, okay? I've rewritten it as a fraction now. And then we just add the dy over dx. And then we do the same thing. We have a u dash times v. So u dash times v, that would give me a 12x over a y. So now that we've done that, okay, we've got 8xy dy over dx plus 4y squared minus 6x squared over y squared dy over dx plus 12x over y. And now for that 10 in the question, well, if we differentiate 10, we just get a 0. And now what we can do is we can put in our values now. So we have x is equal to 1 and y is equal to 1. So we put those values into both x and y, we would end up with 8 dy over dx. That would be plus a 4 minus a 6 dy over dx. And that would be plus a 12, and that would be equal to 0. And if we collect our like terms together, we would get a 8 dy over dx minus a 6 dy over dx. That is a 2 dy over dx. And then, well, we have a positive 16, so we bring it to the other side, it becomes a negative 16. And therefore, if we just divide by 2, we get dy over dx is equal to minus 8. So this question, again, we need to find dy over dx at the point 1, 1, where we have e to the power of 2x ln y is equal to x plus y minus 2. So to do this one, we have that e to the 2x ln y. So first, let's differentiate that. I'm going to use a product rule. If we use product rule, then let's let u equal e to the 2x. Let's let v equal ln y. Then if we differentiate this, we would get a 2e to the 2x. And if we differentiate this, we would get a 1 over y, and then just add the dy over dx. So now that is u times v dash. If we do u times v dash, what do we get? Well, if we do u times v dash, we get a e to the 2x over y, and that is dy over dx. And then we get a u dash times v, which would be a plus 2e to the 2x times ln y. Okay, so now we know that e to the 2x ln y, if we differentiate that, this is everything we get. So now that's the first bit done. Now we have the x, the y, and the minus 2. So if we were to work that out, then, well, x would just go to 1. Our y would become a dy over dx. And that 2 minus 2 would just go to 0, so we don't need to include it. So this is what we've got now. We've got all of this. Now we need to get it in terms of dy over dx. But before we do that, we can put in our values of x and y. So let's do that first. So if we put in our values of x and y, well, what do we get? Well, both x and y are both 1. So if we do that, therefore we get e to the 2 dy over dx minus a 2e to the 2 ln 1 minus a equals a 1 plus dy over dx. So what does this mean? Well, we get an e to the 2 dy over dx. Ln 1 is just 0, so actually that whole thing cancels out. So we're just left with 1 plus dy over dx. And then from this stage here, we can bring that dy over dx to the other side. So e squared dy over dx, and that is minus dy over dx, and that is equal to 1. And then we can get the dy over dx, that would equal e squared to the minus 1 is equal to 1. And therefore, if we just bring that e squared minus 1 to the other side, we get dy over dx equal to 1 over e squared minus 1. Okay, so last question of the day. Now we have this curve C, and we need to find the equation of the tangent to C at the point 1 minus 2, and give an answer in the form ax plus by plus c is equal to 0, where a, b, and c are integers. So let's go with this question. So first things first, we will differentiate everything with respect to x. So that first value would be a 4x. That 3y squared, that will go to a 6y dy over dx. Then we get a minus 1. And then for this one, we can use a product rule. I'm just going to do that in my head to save time. So what would we get? Well, we'd get a 6x dy over dx, okay? And then we would get a 6 plus 6y. That 5 would just go to nothing. And then, again, we're just left with 0. So now we've done that, we can put in our values of x and y. So if we put in our values of x and y, well, we have x equal to 1 and y is equal to minus 2. So therefore, we'd get a 4 minus a 12 dy over dx. We get a minus 1 plus a 6 dy over dx minus a 12, and that is equal to 0. Okay, And now for the next thing, we can collect all our like terms. So we get a minus 6 dy over dx, okay? And that will be equal to, well, what do we have? Well, we have a 4 minus a 1, which is a 3. A 3 minus a 12 is a minus 9. And we're bringing that minus 9 to the other side, so it becomes a positive 9. And now we can just divide by minus 6. So dy over dx is equal to 9 over minus 6, which is minus 3 over 2. So now that we've done that, we know that our m value, our dy over dx, is minus 3 over 2. So now if we write these values down, we know that x is equal to 1. We know that y is equal to minus 2. And we know that our m value is equal to minus 3 over 2. So if we put that into the equation of a straight line, we have y take away y1 is equal to mx take away x1. Therefore, that will be a y minus a minus 2, which makes it a positive, is equal to minus 3 over 2 x minus 1. Then we can multiply everything by 2 to get rid of the fraction. If we do that, we get a 2y, and that is equal to 4 minus 3 x minus 1. And then at this stage, just need to expand the brackets out, so we get a 2y plus 4 is equal to a minus 3x plus 3. And then we need it in that form where ax plus by plus c is all on the same side. So we'll bring everything to the left side. Therefore, we are left with 3x plus 2y. And then we bring that 3, that will become a positive 1. And that is equal to 0. A, B, and C are all integers, and that would be the answer. So I hope you enjoyed this video on implicit differentiation. Remember, if you're ever unsure what to do, you can always think of it and do the product rule or quotient or any other differentiation method in order to work it out. Just remember that y is a function of x, so remember you need that dy over dx in there as well. But I hope you enjoyed this video. If you want to go over some of the other differentiation methods, i.e. the product rule, which I used in this video, then feel free to watch it. I'll put the link somewhere in this video. Okay, but I hope you enjoyed it, and I will see you soon.